everyone, we're going to evaluate the given integral, and let's get started. This is using our table of trigonometric substitutions. It has this form with tangent. So this is what we're going to use, the substitution and the identities here. So to use that, and again, we're going to let x equal tan of theta. This should be negative. So our interval is from negative pi over 2 and pi divided by 2. All right, so our dx would equal secant squared theta d theta. All right, now, so when we substitute, we're going to get square root of 1 plus our tan squared theta. All right, and 1 plus tan squared theta is going to be secant squared theta. And you take the absolute value, but since we're in this quadrant, we're positive. So basically what we really have, once you take care of this part, is secant theta times divided by x, and our x is tan theta, and our dx is secant squared theta d theta. Simplifying all this, let's try to do a little of it here. This is secant and tan, so 1 divided by cosine divided by sine divided by cosine. These cancel, so you're just going to get 1 over cosine, 1 over sine, which is cosecant. So this part's just going to be cosecant theta so you have this, and then secant squared theta is really 1 plus tan squared theta d theta. So when you distribute this, what you're going to get is the integral of cosecant theta plus secant theta tan theta d theta. Now let's break this up, and we're going to get the antiderivative of cosecant of theta plus the antiderivative of secant theta tan theta d theta. Put d theta here, and now we can integrate it. So when you integrate it, from a previous video I did, the antiderivative of cosecant is the absolute value of cosecant theta minus cotan of theta, ln of that, sorry about that. And then plus the antiderivative of secant theta tan theta is secant theta plus c. All right, so again, I did a video on this one to give you that. So now that we have that, what we're going to do is draw, remember we let x equal tan of theta. If I draw a little right triangle here, and let this be my angle, so for tan of this is going to be opposite over adjacent, and when you do the Pythagorean theorem, you're just going to get 1 plus x squared. Therefore, our final answer was ln of cosecant theta minus cotan theta plus secant theta plus c. However, we started with x, so since this is an indefinite integral, we have to put this back in terms of x. And that's where we're going to use the triangle. So we're going to write ln, and then we're going to do cosecant. And cosecant is going to be hypothesis over opposite. So that's just going to be square root of 1 plus x squared divided by x. And then you have cotan, which is going to be 1. Cotan's going to be adjacent over opposite. So that's just going to be 1 divided by x. And then for secant, secant is just going to be hypotenuse over adjacent. So that's going to be square root of 1 plus x squared divided by 1 plus c. Now, the only thing I want to do is simplify this a little bit. So our final answer would be ln of the square root of 1 plus x squared divided by x, and I'm just putting this all over x, plus 1 plus x squared plus c. And that's it. Thank you. Have a nice day. Bye-bye.